section 2.2 is on page 104, and this is continuing the inverse trig function from last class meeting. We covered section 2.1. So 2.2, start off with continuation of where we left off. Find the exact value of each expression. And this is pretty much very close to what we did with a couple of minor changes. So I'll start off with problem number 10. This is in our textbook. This is the page 101. 107, I'm sorry. I thought the page was wrong. I have to go and look. Page 107. So, if I'm looking at this problem, I'm going to have two options for every problem. I'm going to show you both from the very beginning. Two options if you have a standard angle. That is, this is an angle. So I'm looking at the sine of the inverse cosine. And from the previous section, we know inverse cosine is either in quadrant 1 or in quadrant 2. Since this is positive, since this value is positive, I am in quadrant 1, which means just a reference angle. The cosine of which angle gives me a 1/2 in quadrant 1? Well, we know that's pi over 3. Hopefully, either you memorize that unit circle or you're using the triangle like we mentioned. Remember, I could get a quick reference at any given time if I need just the reference angle. If this is 30, that's 1, 2 radical 3. And if this is 45, that is 1, 1 radical 2. I could find the reference angle at any given time of those, and remember that 30 degrees is pi over 3. So if I want the cosine, if I'm asking the cosine of which angle gives me 1/2, it has to be 30 degrees is pi over 6. Oh, today's not my day. Alright. So, and what is the sine of pi over 3? That would be radical 3 over 2. And that would be the final answer. That's one way. I could do this all the time. Or, I could do, if I wish, which is not recommended for this problem, if it's a standard angle, it should fit within what we've been memorizing or understanding, however you want to put it. I could say this is the angle theta. So pretty much I'm looking for the sine of theta. On the side, I say, look, if theta equal the inverse cosine of 1/2, I must have had the cosine of theta equal 1/2. And if you remember, we covered that in section K. I know section K is not in the book, the one we added to the class. So sine inverse is positive. The angle must be in quadrant 1. So you could regenerate the triangle anytime you want. This is the adjacent over the hypotenuse, adjacent over hypotenuse. That makes this a positive radical 3 because you're in quadrant 1. And if you want to know what the sine of that angle is, that would be the opposite over the hypotenuse. So, if it is a standard angle, I'm going to use this process. And if it's not a standard angle, then I must use the triangle. So, just to demonstrate really quickly, just demonstrating, if I alter this problem, if I make that 10 prime and make that a negative, the work is almost identical. That is, 1, if I say, what is my reference angle? My reference angle would still be pi over 3, except I noticed that the inverse cosine is negative, so the angle must be in quadrant 2 for inverse cosine. Again, if you've forgotten, inverse cosine must be in quadrant 1 or 2 if it's positive or negative. Inverse sine, inverse tangent, positive in quadrant 1, negative in quadrant 4. I can only go positive or negative rotation. I can't be in these quadrants anymore. So, I need to know what is this angle in quadrant 2. In quadrant 2, that angle would be 2 pi over 3. And I know the sine of pi over 3 is radical 3 over 2. And in the second quadrant, we know sine is positive. I'm going to also work this out the other case. Or, suppose you had, so I'm doing this as a refresher because this idea is hard to sink in and takes time. Assume this was prime and this is negative. If I wanted to call this angle theta, then I'm really looking for the sine of this angle theta, which I know is the opposite over the hypotenuse. On the side, I'll go in and say, well, if theta equal the inverse cosine of negative 1/2, then the cosine of theta must be negative 1/2. And now when I want to draw the triangle, I could figure out cosine is negative in quadrant 2 or 3. I am certain that angle right there is in quadrant 2 because inverse cosine is only allowed to be in quadrant 1 or 2. Adjacent over hypotenuse, this is negative. In this quadrant, y is positive. And the sine is the opposite over the hypotenuse. How do you do this? It doesn't matter really. It's up to you. If it is a standard angle, I suggest you stick with this. And if it's not a standard angle, there's no way other than